Hi, this is Riaz from Networks Learning. You are watching my YouTube channel, Cisco's Next Generation Firewall Training, Firepower Threat Defense FXOS 7.0. Well, in previous videos, I have explained to you how to configure basic setup of a firewall, how to register it on FMC, and how to configure with its interfaces, zones, uh, and rest of the initial things. In this video, we will take a look on access control policies, their actions and meanings to their actions, and how the packet is inspected and the packet flow inside the next generation firewall. So I have made this topology on PentLab, and my FMC center is running on this ESXi host, and my lab topology is over here. You can see I have quite big lab, but let me explain to you. This is an access layer. Access layer is also configured. Distribution layer, we have VPC configured at access layer and VPC between these distribution switches. Then we have core layer, and back-to-back VPC is configured between distribution and core layer. Then we have firewall layer, and then edge layer. We are working on edge layer and firewall layer. So below the firewall we have configured OSPF area 0, then we have OSPF 0 between distribution and core as well. So entire topology is configured already. I am just showing you the firewall configurations over here. At the end of this series, I will let you see how the entire network is working, and we will make a video to show you the entire packet flow from access layer to the ISP and to the upstream. So coming back to my today's topic, today we will look at access control policies and their actions. Basically, next generation firewall, Cisco's next generation firewall consists of two engines, LINA engine and SNORT engine. LINA comes from Linux and ASA. It's purely ASA. Then SNORT engine, it integrated with ASA. This is a combination. Next generation firewall is combination of two engines, LINA engine and SNORT engine. LINA engine helps you to perform basic functionalities, including ACL, NAT, route, port, protocol based functionalities, just all the things that we perform in traditional ASA firewall. Then comes the SNORT engine. SNORT engine performs the advanced security checks based on the configured access control policies. It has the functionality of performing security intelligence based on different parameters, including IP, reputations, DNS security, URL filtering, malicious URLs, malicious IP addresses. Then it also provides you the layer 7 application control, application visibility, URL filtering, file and name policy. These all functionalities are provided by the SNORT engine. So before moving on to further, we can have a look on this access control policy engines. This is SNORT instance and our LINA engine and SNORT engine. Initially packet comes, it comes to the LINA engine based on the policies configured. Whether it has to go to SNORT engine or not, we can have control over it. And if you don't want to send to the SNORT engine for advanced security checks, then we can move the packet towards LINA engine and egress interface. This is the detailed overview of how we can understand the packet flow inside the Cisco's next generation firewall. First packet comes to ingress interface. Firewall checks for the packet that if it belongs to an existing connection or not. If it belongs to an existing connection, it will fast path the packet towards data acquisition. If it's not the existing connection, then initial checks will be performed. For example, NAT, egress interface, pre-filter policy, layer 3, layer 4 ACLs, and all that which which are written over here. Pre-filter policy is a kind of fast path that you can configure for packets that you think they are trusted and they should be processed uh, fast inside the FTD engines. You can configure. We will configure it and we'll show you the demo how we can configure it and what are the reasons for the traffic that you should configure for under pre-filter policy. Layer 3, layer 4 ACLs are just like we configure in traditional routers. Then the packet goes to data acquisition. Data acquisition is a interface between SNORT engine and the LINA engine. Based on configuration, the packet goes to SNORT engine. At SNORT engine, we have layer 2, layer 4 decoding. Then we have security intelligence, IP-based security intelligence. Based on security intelligence, the IP is dropped. If it is malicious IP address or it is blacklisted IP address, it is dropped. Then the packet goes to SSL decryption. If you are performing SSL decryption in your network, SSL decryption is deep packet inspection, means you decrypt the packet and then re-encrypt. This is quite a security in-depth task that most of the organizations perform today. This is performed this feature helps to monitor and track the encrypted traffic. How you will monitor and how you will ensure that encrypted traffic is checked for security intelligence. So this feature is enabled to perform deep packet inspection or SSL decryption for encrypted traffic. Then we have security intelligence for DNS and URL. Blacklisted URLs are dropped over here. Then we have identity policy. You can configure identification for the users over here. Then we have layer 7 application visibility and control. You can control applications based on your organization's policy. Then we have quality of service classification. You define quality of service policies over here and they are implemented at LINA engine. And then we have network discovery, file policy, M policy, SNORT tools. Then the final verdict is provided to the data acquisition based on SNORT engine configured policies. There are multiple actions based on each policy. We can if you are making a policy based on layer 7 applications, you can have multiple actions against them. You can block them, you can monitor them, you can have an interactive block, or you can just have monitor based on other policies. And the entire packet is inspected against the configured policies and the final decision is taken and the packet is handed over to data acquisition and then follows the rest of the LINA processes and it is egress to the egress interface. So this is quite a high level overview in this diagram, but I have explained this in text format for your easy understanding. So this is the text file which helps you to understand more easily. SNORT engine, its functionality is to perform advanced security checks as per configured rules in the access control policy. It has the functionality of performing security intelligence on IP addresses, IPS SNORT engine for intrusion prevention, security intelligence for DNS, URLs, identity policy for authentication, layer 7 application control and rest of the things. Initially packet ingress to LINA engine based on configured policy at LINA, parameters are checked and packet is forwarded to SNORT engine. SNORT engine checks the policy applied for traffic and returns the packet to the LINA engine. This is quite high level understanding. In LINA engine, initially packet is checked. If it's from existing connection, it follows fast path feature and is handed over to the SNORT engine. If it's new connection, the LINA engine performs VPN decryption and rest of the things and hands over to the pre-filter policy. Pre-filter policy is a mechanism to fast processing of packets. Depending on the nature, we can allow traffic via pre-filter policy to path fast the packets. If packet matches the pre-filter policy, it is forwarded to flow update. Bypassing the rest of the checks on SNORT engine and rest of the data plane processing takes place like NAT, route, etc. If we didn't have pre-filter policy match for traffic, the traffic is inspected on layer 3 and layer 4 is then forwarded to firepower engine, that is SNORT engine. At SNORT, what happens at SNORT? Layer 2, layer 4 lookups are performed. The security intelligence based on IP is done. Reputation based blocking, then application discovery takes place. Internal packet, web packet, Facebook or any packet nature, then security list for DNS, URL and the rest of the things takes place over here. Then layer 7 applications, URL filtering. These are the some kind of explanation which is provided over here. Then we have access control policy configurations best practices. Over here I have FTD firewall. Let me show you the access control policy. I have default access control policy with the name of RGS Campus Access Control Policy. This is the base policy. Inside this policy I have multiple policies. This is mandatory policy, this is default policy. I will explain you the difference between two. And access control policy, this is the main source of policy information for FTD. Main source means it integrates rest of the policies with it, controls how the communication is performed by FTD, acts as master configuration for other policies for individual engines. You can have rest of the things, and let me show you how it's the master for all policies. Here we have networks zones, name of the policy, action. You have multiple actions: allow, trust, monitor, block, interactive block, zones, into mandatory, into default, time range, networks, VLANs, users, applications, ports, URLs, dynamic attributes, inspections, logging and comments. These are some of the multiple policy configurations. However, these are the rules. You have a tab with security intelligence. This is the tab which is integrated. These configurations are integrated with these rules. That's why the access control policy is called the master configuration for other policies. Access control policies consist of two categories: mandatory access control policy and default. If you are following hierarchical policies, these categories only applicable when configuring hierarchical policies. If you are configuring hierarchical policies, then you will go and you have to configure the policies according to mandatory and default access policy configurations. Having more than one policies, we can have base policy, also referred as base template. Under base policy, we can have multiple policies called as child policies. This is the base policy, and in base policy I can have multiple rules and multiple policies and categories. Rules are always processed top-down sequential order. Base policy is the main policy, consists of mandatory rules and default rules. In case of hierarchical code, child policy will consist of the following: base policy. Inside base policy, you create a policy, it will be called as child policy. Child policy, the rules inside the child policy. Because the child policy is part of the base policy, so the rules of the mandatory so the rules of the base policy inside the child policy will always be followed first. Means child policy inside child policy we have mandatory rules of the base policy, we have mandatory rules of the child policy. First it will look on base policy rules inside the child policy, then it will check mandatory rules of the child policy, then it will check default rules of the child policy, then it will check default rules of the base policy. Means the child policy rules are sandwiched between base policy rules. Mandatory rules of the base policy always take precedence over child policy rules. Actions. What are the actions against the policies? We have monitor action. Let me show you the actions which we have. We have allow, trust, monitor, block and rest of the things, and each one is explained over here. Monitor action tracks and logs traffic only. It will not block any traffic. You will always see the logs against this action. Log the communication, but all other rules will also be evaluated. Not final action. It doesn't have the action to perform. It will only monitor the traffic. This action is usually performed when you are deploying the firewall in a transparent environment, in a transparent mode, to monitor the things, or when you are performing POC, for a new project or a new deployment. Then we have the block and reset. Blocks traffic without further processing. If the traffic is TCP, it will reset. If the UDP, it will ICMP unreachable. This is the block action. Interactive block means block and reset. Works with HTTP and HTTPS only. Blocks traffic but displays a warning page allowing users to bypass the block. Bypass traffic is processed like with allow action. Bypass traffic is processed like with allow action. Blocks traffic but displays a warning page. The user is given the user is given the action to perform. He has the right what if he wants to bypass, or he just want to remain with the default action. This is the interactive block. Then we have the allow. In allow, FTD action means inspecting the traffic. If you want to inspect the entire traffic, or you want to perform inspection of all engines at FTD, you can configure a policy with an action of allow. The traffic will be processed by all engines. It will be inspected against all configured policies. All engines are enabled for taking actions for applied policies. Engines take final decisions based on policies configured. Either LINA and SNORT engine can take as per engine's preferred actions. You configure policy at LINA engine, you configure policies at SNORT engine, and based on those, if traffic is allowed, traffic will be passed. If traffic is not allowed and further security checks are not met as per the configured policies, the action will be taken. Then we have the trust. Bypassing SNORT. If you are configuring a policy with the trust action, you are bypassing SNORT engine. File, policy, advanced malware protection, network discovery, inspections. FTD does not perform deep packet inspection on trusted action. If you are making an access control policy with a trust action, the deep packet inspection will not be performed. IPS and file. It means it will not look into intrusion prevention and file and AIM policies. Collectively, it is known as IPS. Inspect with but it will inspect with rest of the security intelligence, identity, and quality of service. Default action of the traffic is traffic not matching any custom rule. Okay, default action. Traffic not matching with any custom rules. Network discovery only. It will only discover the network. Allow all traffic, block all traffic. Two actions. Allow all traffic or block all traffic. The preferred action for default action, the preferred default action is block all traffic, means to block entire traffic. If you are deploying only for IPS, then we have SNORT and network discovery. File and AMP is not supported. Recommendation for next generation IPS deployments. Okay. Then we have network discovery. File and AMP is not supported in that case. Logging is by default disabled on all policies for connections. So going back towards our policies, I have a base policy RGS Campus ACP. In that I haven't configured any rules. So the default action over here is access control block all traffic. I have configured this. You can configure as per your requirement, but I have configured to block all traffic, and I will not be the traffic will not be logged. So let me configure log at beginning of connection for default traffic. Before configuring this, let me show you the configurations or test. So this is my access router. I am on VLAN 12 with 10.12.1.50 IP address on FTD. I can let me show you the interface configuration devices. I have an inside interface with 10.10.199.1. Okay, this firewall is connected with this firewall switch 1, and I am running OSPF, and my access VLAN is terminating on these two firewall switches, and that VLAN is injected into OSPF, and OSPF there's a neighborship between these switches and my firewall. So that's the routing. Let me show you. Either I can ping my firewall internal interface or not. 10.10.199.1 is my firewall inside interface. Okay, this is I'm able to ping this interface. So currently let me ping from firewall. Actually I am able to ping 8.8.8.8. let me show you. From this firewall, outside interface is connected to edge router, and edge router is connected to the ISP. So my connectivity is fine. Let me show you whether I am able to ping to 8.8.8.8 or not. In this case I should not be able to, because I haven't configured any policy yet, but I should see in the events of the traffic which is being blocked by the FTD, but I am not able to see over here. Okay, why? Because the default action configured on this policy for the block traffic is not logged. Okay, the traffic access control block all traffic, but it is not being logged. Let me configure the logging. I've enabled the logging. A policy assignment is my FTD national primary device. Okay, save, deploy. In deployment it will take some time, so I will pause the video, and once the deployment is done I will be back and show you the logs for the block traffic. The process is started. So the FTD firewall policy has successfully been applied, and it's completed. The status is completed. So let me show you the ping response and then the logs at firewall. I have initiated a ICMP from my access device, which is connected over here from this access switch, and let me show you the logs, connection logs at firewall. So this time we should be able to see the logs for the block traffic against my configured policy with the default action of block traffic. So this is the this is the policy, and the default action is block all traffic with logging enabled. Okay, logging. Here we have the connection from the source 10.12.1.50 going to 8.8.8, and it is within action of block. So when we look into it in more detail, we will have clear picture. Action is block, initiator IP is this, responder is 888, type is ICMP, and this access control policy is RGS campus access control, and access control rule is default action. You know, this is the default action. The default action for any kind of traffic is block all traffic. Okay. Default pre-filter policy, we will look into this in an upcoming session. inside interface VLAN. Inside interface is this 199 and outside 201 global. This is how you can have startup from with the access control policies. In coming session, I will explain rest of the configurations and access control policies for my internal network traffic to go onto the internet and rest of the destinations. So thank you so much for viewing this video. I will be uploading more videos that you can with good understanding, so that you can understand and perform these tasks easily. Thank you so much.